Now we will talk about creating a table, writing data to table, reading data from table, and modifying data in table. So now what is table? So tables are fundamental data structures in relational database and in DynamoDB. A relational database management system, that is RDBMS, requires you to define the table schema when you create it. But if you go to AWS, DynamoDB tables are schemaless other than the primary key. So other than the primary key, you do not need to define any attributes or data types at table creation time. Now we will see writing data to table. So relational database tables contains row of datas. Rows are composed of columns. So DynamoDB tables contains items, and items are composed of attributes. Now we will see reading data from table. So with SQL, you use select statement to retrieve one or more rows from a table. You use where clause to determine the data that is returned to you. But in DynamoDB, you can read the item using its primary key. You can query a table. You can scan a table. Now we will talk about modifying data in table. So the SQL language provides the update statement for modifying data. But DynamoDB uses the update item operation to accomplish similar task. So this is basic description of creating a table, writing data to table, reading data from table, and modifying data in table. So we'll see all the concept practically on AWS Management Console in next session. Now we will see how the DynamoDB works. Now we will see the core components of the DynamoDB. So in DynamoDB, tables, items, and attributes are the core components that you work with. A table is a collection of items, and each item is a collection of attributes. DynamoDB uses primary key to uniquely identify each item in a table and secondary index to provide more querying flexibility. So you can use DynamoDB streams to capture data modification events in DynamoDB tables. So let's see what is table. So table, which is similar to other database systems. So DynamoDB stores data in a table. Table is a collection of data. For example, here you can see that this is the people table. So this people table that you could use to store personal contact information about your friends, family, or anyone else of interest. So you could also have a car table to store information about vehicle that people drive. Now let's see what is item. So each table contains multiple items. So an item is a group of attributes that is uniquely identifiable among all of the other items. So here you can see that this is the people table. So each item represents a person. For example, if you have a car table, so each item represents a one vehicle. So the items in DynamoDB are similar in many ways to rows, records, or tuples in other database systems. In DynamoDB, there is no limit to number of items you can store in table. Now let's see what is attributes. So each item is composed of one or more attributes. So an attribute is a fundamental data element, something that does not need to be broken down any further. For example, an item in a people table contains attributes called as person ID, last name, first name, and so on. And if you consider some department table, so an item might have attributes such as department ID, name, manager, and so on. The attributes in DynamoDB are similar in many ways to fields or columns in other database systems. Now let's see what is primary and sort key. So when you create a table, in addition to the table name, you must specify the primary key of the table. The primary key uniquely identifies each item in a table so that no two items can have the same key. So DynamoDB supports two different kinds of primary key. So first is partition key, that is a simple primary key composed of one attribute known as partition key. So if you see this table, we have a artist. So this is nothing but one primary key, that is partition key. So DynamoDB uses the partition key's value, for example this is value, as input to internal hash function. The output from hash function determines the partition in which the item will be stored. In a table that has only one partition key, no two items can have same partition key value. Now let's see what is partitions key and sort key. So this is known as composite primary key. This type of key is composed of two attributes. So here you can see that this is one partition key and this is sort key. So this is also known as composite primary key. So DynamoDB uses the partition key value as input to internal hash function. The output from hash function determines the partition in which the item will be stored. So all the items with same partition key are stored together in sorted order by sort key value. So in a table that has a partition key and sort key, it is possible for two items to have same partition key value. So here you can see that this is the partition key which has same value. Here you can see that this is the value, no one you know. So this is same value. So this partition key value will be same, but the sort key value will be different. So those two items must have different sort key values. Now we will talk about secondary index and streams. So what is meant by secondary index in DynamoDB? So you can create one or more secondary index on a table. A secondary index lets you query the data in a table using an alternate key in addition to query against primary key. So DynamoDB does not require that you use indexes, but they give your application more flexibility when querying your data. So after you create a secondary index on table, you can read data from the index in much same way as you do from the table. So here you can see that this is the music table and we have a genre album title. So this is one secondary index. So basically DynamoDB supports two kinds of indexes. First is global secondary index and second is local secondary index. So what is meant by global secondary index? So an index with a partition key and sort key that can be different from those on table. And what is meant by local secondary index? So an index that has the same partition key as a table but different sort key. So here you can see that this is the music table which has a partition key as artist and sort key as a song title. And if you see the index, secondary index, so this index which has a partition key and sort key both together different. So this is known as global secondary index which has both partition key and sort key are different from those on the table. So this is the example of music table. So you can query data items by artist or by artist and song title. What if you want to query the data by genre item and album title. So in that case, you have to create a secondary index. So here you can see that this is the global secondary index. So genre and album title, so both the partition key and sort key are different from the music table. So this is known as global secondary index. So after creating the index, you can query the index in much the same way as you did query the music table. So this concept known as secondary index. Now we will see what is streams. DynamoDB streams. So DynamoDB streams is an optional feature that captures the data modification events in DynamoDB tables. The data about these events appear in the stream in near real time and in order that event occurred. Each event is represented by stream record. So if you enable a stream on a table, DynamoDB streams write a stream record whenever the events occur. So first event is, so if new item is added to the table, the stream captures an image of entire item including all of its attributes. Second event, if an item is updated, the stream captures the before and after image of any attributes that were modified in the item. And third event is, if an item is deleted from the table, the stream captures an image of entire item before it was deleted. So each stream record also contains the name of the table, the event timestamp and other metadata. Stream records have a lifetime of 24 hours. After that, they are automatically removed from the stream. So you can use DynamoDB streams together with AWS Lambda to create a trigger event that executes automatically whenever an event of the interest appears in the stream. So here you can see that, for example, a customer table. So this is the customer table that contains customer information for a company. Suppose that you want to send a welcome email to each new customer. So you could enable a stream on the table and then associate the stream with a Lambda function. So here you can see that we have a Lambda function and the stream which is associated with the Lambda function. So the Lambda function would execute whenever a new stream record appears, but only process new items added to the customer table. For any item that has an email address attribute, the Lambda function would invoke Amazon SES, that is Simple Email Service, to send an email to that address. So this is the concept of DynamoDB streams. So we will see how to create a table, how to put the item in a table, how to create a secondary index for the table practically on AWS Management Console in next sessions. Thank you. Now we will talk about throughput capacity for reads and writes. So when you create a table or index in DynamoDB, you must specify your capacity requirements for read and write activity. So by defining your throughput capacity in advance, Amazon DynamoDB can reserve the necessary resources to meet the read and write activity your application requires, while ensuring consistent low latency performance. So you specify throughput capacity in terms of read capacity unit and write capacity unit. So one read capacity unit represents one strongly consistent read per second or two eventually consistent read per second for an item up to 4 KB in size. So if you need to read an item that is larger than 4 KB, DynamoDB will need to consume additional read capacity units. The total number of read capacity units required depends on the item size and whether you want an eventually consistent or strongly consistent read. And one write capacity unit represents one write per second for an item up to 1 KB in size. If you need to write an item that is larger than 1 KB, then DynamoDB will need to consume additional write capacity units. The total number of write capacity units required depends on the item size. Suppose, take an example that you have created one table with 5 read capacity unit and 5 write capacity unit. So with this setting, your application perform strongly consistent read up to 20 KB per second. That means 4 KB into 5 read capacity units. So your application perform eventually consistent read up to 40 KB per second. That is twice as much read throughput. And last is your application can write up to 5 KB per second. That is 1 KB into 5 write capacity units. So DynamoDB provides 3 different mechanisms for managing throughput. So here you can see that first is DynamoDB auto scaling, second is provision throughput, and third is reserve capacity. So we'll talk all the 3 mechanisms for managing throughput in next session. Now we will talk about mechanism for managing throughput. So first is DynamoDB auto scaling. The DynamoDB autoscaling actively manages throughput capacity for tables and global secondary indexes. With autoscaling, you can define a range for read and write capacity units. You also define a target utilization percentage within that range. So DynamoDB autoscaling seeks to maintain your target utilization even as your application workload increases or decreases. With DynamoDB autoscaling, a table or a global secondary index can increase its provision read and write capacity units to handle sudden increases in traffic without request throttling. When the workload decreases, Amazon DynamoDB autoscaling can decrease the throughput so that you don't pay for unused provision capacity. So this is the concept of DynamoDB autoscaling. Now we will see provision throughput. If you are not using DynamoDB autoscaling, you have to manually define your throughput requirements. So provision throughput is the maximum amount of capacity that an application can consume from a table or index. If your application exceeds your provision throughput settings, it is subject to request throttling. Suppose, take an example that you want to read 80 items per second from a table and those items are 3 KB in size and you want strongly consistent reads. So for this scenario, each read requires one provision read capacity unit. So to determine this, you divide the item size of the operation by 4 KB and then round up to the nearest whole number. For example, we have item size 3 KB. So 3 KB divided by 4 KB is equal to 0.75 or 1 read capacity unit. So for this scenario, you have to set the table's provision read throughput to 80 read capacity units. So 1 read capacity unit per item into 80, that is 80 read capacity units. Now suppose that you want to write 100 items per second to your table and that the items are 512 bytes in size. So for this scenario, each write requires one provision write capacity unit. So to determine this, you divide the item size of operation by 1 KB. So the item size is 512 bytes divided by 1 KB, that is 0.5 or 1. So for this scenario, you would want to set the table's provision write throughput to 100 write capacity units. So 1 write capacity unit per item into 100 write per second is equal to 100 write capacity units. So this is the concept of provision throughput. Now we will see reserve capacity. As a DynamoDB customer, you can purchase reserve capacity in advance, as described at Amazon DynamoDB pricing. With reserve capacity, you pay one-time upfront fee and commit to a minimum usage level over a period of time. By reserving your read and write capacity units ahead of time, you realize significant cost saving compared to on-demand provision throughput setting. So this is the concept of reserve capacity. So these are the three mechanisms for managing throughput. So we will talk other concept of DynamoDB in next session. Now we will talk about partition and data distribution. DynamoDB stores data in partitions. A partition is an allocation of storage for a table backed by solid-state drives, that is SSDs, and automatically replicated across multiple availability zones within an AWS region. Partition management is handled entirely by DynamoDB. You never have to manage partitions yourself. So when you create a table, the initial status of the table is creating. During this phase, DynamoDB allocates sufficient partitions to the table so that it can handle your provision throughput requirements. You can begin writing and reading table data after the table status change to active. DynamoDB allocates additional partition to a table in two situations. First situation is if you increase the table's provision throughput settings beyond what the existing partition can support. And second is if an existing partition fills to capacity and more storage space is required. So this is the concept of partition and data distribution. Now we will see data distribution for partition key. So if your table has a simple primary key, that is partition key. So here you can see that. So for example, I have a table and the partition key is animal type and the partition key value is dog. So if your table has a simple primary key, so DynamoDB stores and retrieves each item based on its primary key value. To write an item to a table, DynamoDB uses the value of partition key as input to an hash function. So here you can see that. So the partition key value will be given to the hash function. The output value from hash function determines the partition in which the item will be stored. So here you can see that this is the one partition where your item will be stored. To read an item from the table, you must specify the partition key value for the item. DynamoDB uses this value as input to its hash function, yielding the partition in which item can be found. So this is the concept of data distribution for partition key. Now we will talk data distribution for partition key and sort key. So if the table has a composite primary key, that is partition key and sort key. So here you can see that this is the one table which has a partition key and a sort key. The DynamoDB calculates the hash value of the partition key in same way as described in data distribution for partition key. But it stores all of the items with same partition key value physically close together, ordered by sort key value. So here you can see that. So animal type is the partition key and name is the sort key. So if you are creating a table which has a partition key and sort key, so the DynamoDB will store all the items which has same partition key physically close together, ordered by sort key value. To write an item to a table, DynamoDB calculates the hash value of the partition key to determine which partition should contain the item. In that partition, there could be several items with same partition key value. So DynamoDB stores the item among the others with same partition key in ascending order by sort key. To read an item from a table, you must specify its partition key value and sort key value. DynamoDB calculates the partition key's hash value, yielding the partition in which item can be found. So you can read multiple items from the table in significant operation, which means query, provided that the items you want have the same partition key value. DynamoDB returns all of the items with that partition key value. And optionally, you can apply a condition to the sort key so that it returns only the items within a certain range of values. So this is the concept of data distribution for partition key and sort key. Now we will talk about from SQL to NoSQL. So if you are an application developer, you might have some experience using relational database management system and structured query language, that is SQL. So as you begin working with Amazon DynamoDB, you will encounter many similarities but also many things that are different. So this describes the common database task comparing and contrasting SQL statement with their equivalent DynamoDB operation. NoSQL is a term used to describe non-relational database systems that are highly available, scalable, and optimized for high performance. Instead of relational model, NoSQL database like Amazon DynamoDB use alternate models for data management such as key value pairs or document storage. Now we will see SQL or NoSQL. So today's applications have more demanding requirements than ever before. For example, an online game might start out with just few users and very small amount of data. However, if the game becomes successful, it can easily outstrip the resource of underlying database management system. It is not common for web-based application to have hundreds, thousands or millions of concurrent users with terabytes or more of new data generated per day. So databases for such application must handle tens of thousands of reads and writes per second. So Amazon DynamoDB is well suited for these kinds of workloads. As a developer, you can start with small amount of provision throughput and gradually increase it as your application becomes more popular. So Amazon DynamoDB scales seamlessly to handle very large amount of data and very large number of users. Now we will see accessing the database. So before your application can access the database, it must be authenticated to ensure that application is allowed to use the database and authorized so that the application can only perform actions for which it has permission. Now we will talk about the comparison of SQL and Amazon DynamoDB. So first is tools for accessing database. So if you have SQL, then the relational database provides a command line interface so that you can enter ad hoc SQL statement and see the results immediately. But if you go to Amazon DynamoDB, in most cases you write the application code. You can also use the AWS Management Console or AWS command line interface to send ad hoc requests to DynamoDB and view the result. Now second is connecting to database. So in SQL, an application program establishes and maintains a network connection with database. When the application is finished, it terminates the connection. So here you can see that this is the user, he writes a SQL statement and the database will give the response from the database. If you go to AWS DynamoDB, so DynamoDB is a web service and interaction with it are stateless. Applications do not need to maintain persistent network connection. Instead, interaction with DynamoDB occurs using HTTP request and response. So here you can see that this is the user. So he will send a HTTP post request which will go to AWS DynamoDB and DynamoDB will return the HTTP reply to the user. Now third is sending a request. So in SQL, the application issues a SQL statement for every database operation that it wants to perform. Upon receipt of SQL statement, the RDBMS checks its syntax, creates a plan for performing the operation, and then executes the plan. But if you go to Amazon DynamoDB, the application sends the HTTP request to DynamoDB. The request contains the name of the DynamoDB operations to perform along with parameters. So DynamoDB executes the request immediately and it will give the response. Now last is receiving a response. So in SQL, the RDBMS returns the results from SQL statement. So if there is an error, the RDBMS returns an error status and message. But if you go to Amazon DynamoDB, DynamoDB returns an HTTP response containing the results of operation. So if there is an error, DynamoDB returns an HTTP error status and message. So these four are the comparison points for SQL and AWS DynamoDB. So we will see the other four topics in next session.